episode 231. Welcome to Data Skeptic, a podcast about data science and fake news from an algorithmic perspective. Here's your host, Kyle Polich.
Well, Linda, I want to pick up on a topic we were covering last time, click-through rates, CTRs, right? And talk about another step, and that's quality score. Do you know anything about quality score?
I don't know, but I'm sure it's some kind of metric Google made up to measure something.
Yeah. So before we get into the exact definition, let's remind ourselves about CTR, why it was good. Click-through rates have sort of an obvious goodness about them, that if people are clicking on something, they're showing interest. If you show them more interesting things, that sounds smart, right?
Yeah.
So if you were to algorithmically rank search results or content of any kind by like the CTR descending, that sounds pretty good, right, in theory?
From ascending to descending?
Yeah, highest ones go to the top.
Yeah.
Now you got some problems with like the cold start problem. How does a new piece of content get ranked? But setting that aside, what could go wrong if we just ranked all of the content on the internet by its CTR?
I think some things like the tabloids might get a lot of clicks, but maybe the tabloids aren't a reputable news source.
But people are clicking on them. That's what they want, right?
Yeah, but I click on things that I don't really should read. Like it'll be like, what did Princess Middleton wear? And I'll be like, ooh, what did she wear? And then I don't really want to know, but it just showed up.
Well, this sounds more like a personal problem.
I know. I looked through some photos of Princess Middleton and now Google thinks all I want to know about is Princess Middleton. It's so annoying. They'll be like, look what she wore. I'm like, no, stop.
Well, let me make it even worse than that. Maybe if I want my ad to get clicked on the most, I would say something like, click here and get $200 for free.
Yeah.
I mean, I hope that's illegal. It's some form of like false advertising or something like that. But obviously, if all you care about is getting an ad clicked on, then people will create very manipulative ads, right?
Well, they already do.
And, maybe if I was like some nefarious site or some, whatever e-commerce platform that I just want lots of traffic, I would bid on a search term like rental cars. And then I would have an ad that says cheapest rental cars in town. And when you click on it, suddenly you're at like a random page on an e-commerce site. That's not what you want.
Nope.
Have you ever had an experience like that on the internet?
Usually my experience is trying to get out of an ad, but then I accidentally click on an ad. And they get money for that.
Right.
So annoying.
Yeah, there's a lot of fraud in that area as well. That's a whole topic for another show. I'm focused less on like the shenanigans with JavaScript and clicking and more on like, what can you do to manipulate people and influence them to click an ad? Because obviously, if there's like a clothing company and you're searching for clothes, they want to optimize their ad. They want to make it more and more appropriate to draw you in, right?
Yeah.
It's their sales pitch. Make a good sales pitch. That's ad optimization.
Okay.
So how do you think one can tell the difference between run-of-the-mill ad optimization, updating your wording, and being manipulative?
It's probably not a straight black and white, right? It's a gradient. And how misleading are you trying to be?
That's true. So all of this is a bit like Goodhart's Law that we talked about a long, long time ago. If people didn't catch that episode, I'll put it in the show notes. But I can think of a couple ways maybe I would manipulate the click-through rate, even without changing the ad copy. Like maybe we could lock that down. If I wanted to get my things ranked higher, maybe I would go and click on them myself. Now, I might have to pay for those clicks, but if that cost gets me higher in the rank and gets me more exposure, maybe there's a cost-benefit analysis and I decide that it's worth doing that, even though it's kind of manipulative.
Yep, I think people do that, just like when people put fake Amazon reviews.
Yeah, and people will click their competitor's ad. Now, in this case, if you were just talking about click-through rates, it would drive that up, but it would also cost them money, right? So the manipulation goes both ways.
Mm-hmm.
Certainly, there are some very sophisticated algorithms at play trying to filter that out, dedupe stuff, fraud, botnets, all that kind of stuff. Topic for a different day. Let's just explore what then these ad platforms had to do to go beyond click-through rate. The one I'm most familiar with is something called quality score, which is at play in Google's AdWords product. I imagine it's in a lot of other ad systems as well. That's just the one I've worked with the most, so I know it the best. I'm sure Bing's system has the equivalent, and lots of other ad places have a quality score. Just knowing the name, what would you think that it attempts to measure?
What's the name again?
Quality score.
Oh, sorry. Yeah, we talked about this earlier. Probably the quality of your ad. Or reliability?
Well, what else do you have, though, if the ad goes somewhere, right?
Yeah.
So what can you do with that? You have more information you haven't used yet.
So what's the question here?
if you wanted to develop this quality score, what are the inputs you can use? The ad copy, obviously.
So what is the quality score? Let's define that first.
Mm-hmm.
So what is that? What do you mean?
The quality score is some measurement of how appropriate the content is for the user.
So do you measure it by bounce rate?
That's an interesting idea. Absolutely, you could look at that. So for listeners that don't know, could you describe that?
Bounce rate. I don't know what they define it as, but it's like how long do people stay on your site and how many people go to it and immediately are like, oh, I'm on the wrong site, hit back or whatever, or close the tab.
So that's an excellent measurement. Why though?
Because if you're just getting accidental clicks, like I talked about earlier, that would lead to a high bounce rate because I didn't really want to click to begin with.
What if there's like speed readers and they're just able to be very efficient?
Well, the odds are when you're on a site and they're trying to get you to spend money, it probably takes longer than 0.02 seconds to spend your money.
Yeah, even a speed reader is probably not going to be done that quick. And if there are speed readers, they're probably uniformly distributed amongst, the population. So they would affect all ads equally, we might say. So yeah, how quickly people leave is a nice measurement of how much they're enjoying the content. Although it is tricky, right? Because if I click on a page and it's something on the Gutenberg archive and it's an entire book, I might be on it for hours. Whereas if I just hit some random e-commerce site and I see the item I want's not there, I might be out right away.
I don't know. I feel like it would be wildly inaccurate. It just depends what people want to do. Like if you want to read an article on the site, it probably takes like 5 minutes to read an article.
Yeah, but of course you want some formula or algorithm that's fair for all ads. You don't want to have some specialized algorithm that only works for legal ads and then a different one for plumbing ads and a different one for car sales ads. It doesn't make sense.
So how do they solve this problem? What do they do?
Well, all right, so if anyone knows this system intimately, they're going to call me out on this because I'm very aware it's more complicated than this. But if we were starting from scratch and building a prototype, a very nice place to start, which is how I think most of these ad systems started originally, was click-through rate, as we've talked about, multiplied by the quality score. So that way, even if you have a high click-through rate, if you have a very, very small quality score, large number times small number, the small number scales it down.
And what's this number the result of? What
that would be called like your search rank or your search score.
And that's your search score.
The higher the better. The higher you get, the higher you appear on the page.
So this is how most search engines work?
Well, we've been talking mainly about ads. Search engines definitely use elements of this as well, but they look more at page content, whereas ads, because pages don't say, hey, show me for this keyword. Actually, you can stick that in your metadata of your page, but I'm pretty sure everyone ignores that because it's kind of silly. Mostly the search engine decides what pages to show for a certain result. When it comes to ads, the ad says, I want to appear under this keyword. Can you please show me there? And then the ad engine has to state the price. And then based on the price, combined with the click-through rate and the quality scores where you would rank. Hey, Data Skeptic listeners. I want to talk to you for a minute about the computer memory course you can find over at brilliant.org. I meet a lot of data scientists who don't really take the time to learn certain key fundamentals, like knowing how your computer's memory works. If that's you, it's time to take the first step by heading over to brilliant.org/dataskeptic. Click on the courses section and pick computer memory. Then enjoy the smooth, bite-sized teaching style used at Brilliant as their platform guides you to a deep level of expertise on this topic. Trust me, you really need to know about computer memory if you're interested in data. When I work on projects, I'm always trying to push the limits of what I can do on a single machine. I only take it to distributed computing, it's more complications when I need to. And the only reason I can get the most out of my algorithms on that single machine is because I understand the details of performance tuning, virtual memory, and what services the operating system is providing and stuff they're not providing, like garbage collection. If you want to be a serious data scientist who really builds awesome stuff, but you're not clear on concepts like swapping and caching and the heap, then today's the day to push your career forward. And one way that you do that is by learning about computer memory on this fun and easy platform. Send an HTTP or HTTPS GET request to brilliant.org/dataskeptic to get started. Once again, that's brilliant.org/dataskeptic.
So you said other people would claim you oversimplified it. So what are the things that you're not taking into account here?
Well, right there, the cost, how you figure in, how much more you bid. There's a pretty standard way of doing that called the second bid or Vickery auction. That's a topic for another show. But let's just break apart what that quality score would be. We talked about looking at the ad itself, maybe making sure it's not spammy in some way. That's a good idea. Looking at the time on page, like you said. You could also crawl the page and look at its content. For example, if the keyword being searched does not actually appear on the page, then maybe that's not a good result page, right?
Oh, well, so you search the word search.
Well, maybe do a less convoluted
Is that what you're
example.
saying? Is that your example?
No, how about search the word rental cars?
Oh, okay. So you search the word rental car, and you're saying the word rental car if it doesn't show up on the page. Well, why would you even provide that result?
Well, that's exactly right. The search engine or the advertising platform would not want that result to show. So let's say right now I went and I set up an ad and I wanted people who search for rental cars to be shown an ad for dataskeptic.com. That would not be a positive result from the search point of view, and most likely people wouldn't click it, right?
That's a good question.
I could say, hey, podcast all about the best prices on car rentals, and maybe people would be fooled by that and want to click it.
Well, maybe if your podcast had an episode about, trying to hack the system of car rental cars.
Or some sort of analysis.
Then maybe people would click on it, but, probably not. What I think you're saying is not an efficient use of your ad budget.
Well, the ad platform wants to punish you for trying to do that because that's a spammy thing to do. And they could just block you if they want to in some way, but usually they make it more organic. They say that, if you want to appear for this search term, because your quality score is so low, you have to pay a very high price. Maybe a legitimate car rental company would pay $4 a click. They would ask Data Skeptic to pay $20 a click because we really aren't appropriate for that search result.
Mm-hmm.
And how do they know that? They know that not just because of our click-through rate, because we could have a misleading ad, but they know it from our quality score, because presumably they crawled our page and they said, hey, the content of this page seems to be about machine learning, not about car rentals and stuff like that, and pretty much any other metadata you could find. Actually, for me, this is the most exciting part of a data science project is right here. Rewind to maybe 1995 when people were figuring this stuff out. I wish I'd been able to work on problems like this, where you're thinking okay, users are sending us search terms and we want to show them high quality results. That sounds intuitive, but we have to define it mathematically. What does it mean?
Are those things you think about coming up with a way to define quality results? Do you come up with these kinds of things in your problems?
Yeah, different iterations on themes like this. So if I'm confronted with a situation like this, I would say, well, I need to do some feature engineering now. So I need to get, crawl the page and convert that into features. Get a hold of that, what did you call it?
Bounce rate?
Bounce rate, yeah. Get a hold of the bounce rate. I think it's called bulk rate in some analytics systems.
Oh.
Bounce is more for emails that came back undeliverable. But then I could also look at the page load speed. And I know that search engines do this. If pages load too slow, they'll show them less often or not at all. Maybe look at whether or not the page seems to be formatted well or looks like a crappy old page that people don't like to browse,
So wait, where's an example where you came up with your own kind of quality score metric?
Well, I can't get into too many specifics, but in working on a fraud detection problem, for example, the fraudulent users are doing their best to not appear as fraud. So I had to come up with, what are some features we could look at that would help us separate the data and determine good users from bad ones? So I'll share some obvious stuff that aren't trade secrets or anything. Look and see, does the IP address correspond geographically to the credit card number and where the user says they're from, right? So if you're I'm somebody in Iowa, but you have a Russian IP address, then probably that's fraudulent.
So this is common where you guys want to come up with some quality ranking or score, and you might come up with your own way to figure it out.
Yeah, there's no access to ground truth. There is no, oracle that will look at a web page and say, this is of high quality for this search keyword. So you have to come up with some formula or algorithm that does it. In the ad space, it's to make a more economical ad platform, to penalize advertisers who are serving up bad content and to help users find good content. And the click-through rate alone wasn't good enough, so they came up with this idea of quality score, which is judging the value of the content.
So how does this relate to fake news?
Good question. If they could, social media sites might crawl these pages, and instead of having a quality score, they would have a truthiness score. And then they could algorithmically leverage that. So things that have a low truthiness score, they have a less likelihood to show.
And who should have the ability to censor what we read?
Well, that's interesting. I think that's a separate discussion. It's a step downstream from this. If first we just want to establish, does this piece of content represent the truth? That's actually, there's no moral question there. It does or it doesn't. The hard part is actually coming up with an algorithm that does that.
Well, let's say you're one of those people who don't believe humans landed on the moon. What is this called? Conspiracy people.
Yeah.
So if you truly
moon landing hoaxer.
So if you truly have this perspective where you think it's real, so you're saying the truthiness detector is going to base it on facts and generally accepted knowledge and practices.
Well, that would be wonderful if we had such a tool, yes.
Yep. I mean, with the example of Donald Trump signed a bill that didn't or did benefit a certain segment of people, you could show one opinion piece that says it does, and then at the bottom of the page, you could then show opinion pieces of the opposing side.
Yeah. And what if it's a bill that's going to, almost for sure, cut jobs, but part of the bill is that they're going to get stipends for education? Right? So does that benefit them or not? Well, that's now certainly a matter of opinion, but that could factually be in the bill.
Yeah. So what's your
well, I guess
stance? I don't know what you're saying.
I'm saying that this idea of a truthiness detector seems to be a bit of a fiction. I mean, we have fact-checking sites and stuff like that, and I hope to talk to some of those on future episodes of the podcast. But basically, we're not going to solve fake news if we want to filter it or control the content. We're not going to be able to do it in the same ways that things like spam filtering were solved. We're not going to be able to do it in the same way that ad filtering was solved. We need some new ideas.
So where are those new ideas?
Well, many of them are coming from some of the recent guests I've had on the show who are talking about their applications of machine learning to this problem. But ultimately, it's, history in motion. We don't know what's going to happen exactly.
Well, what do you think should happen? If you're the data skeptic and you're an expert in this field, what do you think is the best, most compelling solutions?
Well, I'm prepared to comment on methodologies and how they might accomplish certain tasks. I don't want to get into what should or shouldn't be done. For example, Facebook, should they be filtering fake news, more than they do? I mean, everyone kind of wants to say yes, because, frankly, Facebook says, yes, we should do this more. But there will be this question of, is Facebook doing a good enough job? And I don't know that there's a answer from first principles that can be derived about that. So I will steer clear about how much responsibility the platforms owe to the public or whatever, because that's a little weird. I just want to comment on how effective will their strategies be and how might they detect and label this stuff if they were interested in doing so. So I feel like we didn't talk enough about quality score. Do you feel like you've gotten the basic idea of what it is and why it exists?
Seems like it's made up, but it was made up to solve a problem.
Yeah.
And then I'm assuming they probably roll out different solutions now, because it's been many years since that's been made up.
Yeah, so I imagine there have been great advancements in how the quality score is computed, like crawling the page and analyzing it. That's probably gotten more sophisticated from the earliest days of this stuff. And then even what other factors go into this, into your ranking should matter. But anyway, those are some of the things I know about quality scores from my days doing automated ad optimization.
Automated ad optimization. Mm-hmm. The good old days.
I think that's good for today. Well, thanks as always for joining me, Linda.
Thank you, Kyle.
Thanks for listening to Data Skeptic, where the news may be fake, but the data doesn't lie. Support the show and find extended materials at dataskeptic.com.